programming and stuff like that is just... That's why I think it's... Like, I tried to teach programming to, like, my brother at one point, and I sucked at it. Like, I sucked at teaching him programming, and I didn't think I did, of course, because I was, because, whenever I do something, I think I'm super smart, because I'm super smart, man. It was basically like, whenever he would write something in this code that he was, just learning how to write, he would write a really shitty version of whatever the hell needed to be written. And the thing is, he actually, which is fine. That's what you're supposed to do when you're learning like a new programming language. But every time he did something, I'd always have something else he could do better. Like, oh, you should have made this a function, or you should have made this a class, and you should have called this and like packaged this up. And when he would try to follow some of that advice, he would be completely lost as to how to do anything, right? Because, all of a sudden, lesson 2 of C++, I'm trying to print out hello world, is you now have like a full class structure hierarchy for all your crap, and you have no idea even why you would use it. And after a while, I realized there's not something wrong with him, there's something wrong with me. I am shit at teaching this. And it's because I wasn't letting him make mistakes, like I was correcting everything that you need to, the only way to learn, like, I think good class hierarchy and everything like that is to make a horrible, shitty class hierarchy and then see how it works or doesn't work. So it was one of those where I was like, you know what? My teachers did a much better job of teaching this crap because they were teachers and they knew how to actually communicate with people who were learning and understand and kind of disconnect and be like, you need to just go make those mistakes. So just copy pasta the hell out of this because we can do that. Here it is, repulsion map. So hooray, we now have that. And if we need to go do anything else with the repulsion map, we can. Alright, so we need to define that function, right? We didn't actually... And that was definitely when I tried to help my brother out when I was working on certain things. That helped me out later when I was trying to teach other people programming practices or whatever, when I was the lead on the team or something and like needing to teach somebody something. And just being like, you know what, you're writing this. This is your code. I'm not going to tell you everything about it. I pretty much would tell people, like, does it work? Okay, then it works and we're good. And that became the most important thing. Alright, so we got our flow inputs, we got everything like that. So what we're going to do now is detect those things. Alright, so we're going to use a radius, or are we just going to use like a plus sign like we were using? I think we're just going to use a plus sign as well for this. So float repulse weight equals flow field dot m. What the hell did I even call that? Repulsion weight. So we're gonna add this in here. This will be repulse vector multiplied by repulse weight. And this is starting to become some ridiculous garbage code for this tick method. I love it. Alright, so we're gonna do another plus for this crap. We're never normalizing our repulse vector, our drain vector. There we go. I wonder if some of those things were all sorts of screwed. This will be our repulse vector. repulsion detect distance. So what I'm going to do here is I'm going to throw some of these in some arbitrary scopes. And I kind of do that to give myself a hint that I should probably remove that code or change it somehow. And I also do that to kind of protect myself if there's any variables that are being used by those other scopes, it'll immediately become a compile error. That's kind of how I deal with dealing with crappy code and turning it into better code later, perhaps. So usually chuck it inside of a scope, just be like, yeah, this chunk right here is garbage, but it should be garbage that at least doesn't run into anything else. So it can be cleaned up, and it's at least not crapping up the rest of the stuff with variables, stuff that we might accidentally use. That's pretty funny. I check Facebook and I'm like, oh, I got a whole bunch of notifications. I wonder what's going on. Ah, Lucas liked everything on the Dashkin page. Good job, Lucas. Alright, so our repulse weights are in there. Our blueprint needs those values added to it so we can go mess with stuff. So let's see, our drain attract weight and the drain detect distance. Alright, so this is going to be the repulse weight and the repulse detect distance. Alright, so this is how strongly a particle is repulsed from usually an input area. And this is how close to a repulse area we detect the repulse. Yeah, the stream kind of down. Yeah, that's true. That's probably for the best. I don't say anything that's worth hearing anyway. Let's be honest. It's like the drone of some like engine in the background. You just tune it out. Alright, so we should have our repulse stuff here then. So we should be repulsed only around here. Let me go check exactly what that should look like. Like, is this a... Alright, so waterfall N is a radius of 2000, so it should be decently large. Like, there should be a circle there that's about, what, 14 pixels wide? And we should see stuff head away from it. So let's see if that actually does what we think it'll do. Oh yeah, it'll crash because we never initialized our map here. It's just because you're drawing. Drawing's important, Lucas. Keep drawing. Become better. What is that? The concept that one of my professors was saying is, improve a little bit every day. Every day you should become better at something, or you should become less bad at something. As if you're relaxing, you are becoming less stressed. You are becoming a stronger person. If you are practicing something, you are becoming better at it. So every day, become better. And I think that's called Kaizen, is what he would say. I don't think we did this right. I think we did this wrong. And at the back of my mind, it was saying, your directions are wrong. It's saying the repulse vector needs to be away from the detected space's repulse, not towards it. That's an attraction. It's an attraction force. And what did we set for the repulse weight? And we're not even initializing these things. This is just super sloppy. Who wrote this? Oh, I wrote this. How many times does that happen when you're programming or something? And you're looking over some old code, you're just like, who the hell wrote this crap? This is all garbage. And then you look at the top of the file and you're like, damn. Well, I guess it's not garbage. It's still garbage. So get our repulsion in here. Alright, let's see what it looks like. Let's make sure we're actually using this. Are we normalizing our repulse vector? Yeah. I'd kind of like to add a little repulse area or something like that without adding a new input. Kind of like throw a little repulse thing like right here or something. Maybe I should throw one like around this rock and move it over a little bit. I want to see what it looks like. Alright, let's void add repulse area. And it'll be a water flow object, which makes total sense if it's a water flow object. Water flow objects are supposed to be these sorts of things. And what we're going to do here is I guess we're just going to rename this function to this, and that actually serves our purpose. Alright, so let's have our inputs and outputs and our repulse areas. Alright. Alright, so this location, let's take a look at this. I copied and pasted the location already. So negative 4,000 is there for the Z. The Y was negative 13,200. Oh yeah, that's how you write 13,200. Jesus. And the X was 78. So it's like this. And I'm just going to say repulse 1. Input is true. Input is false. Let's give it a large radius. 3,000. Let's see what it does. Ah, I'm adding it to the inputs. I don't want that. Alright, so the Y direction, I want to move it in the X direction, so I think negative X, so I want to move it like, it needs to be like 7,400, 74,000 maybe? Is that a fucking spider? Uh-oh. That was like one of those little baby spiders that, like, when they come out, there's like... Well, I just kicked my mic cord. I'm sorry about that, if that destroyed anybody's ears. That was completely not on purpose. Yeah. So if I somehow get swarmed by thousands of baby spiders here in another 5 minutes, I hope that I die well. That's what happens when you have your office in a basement. Yeah. In other news, my house is now burning to the ground. Alright, so we should see a repulse field about here. Yeah, you can see what's happening is, like, this is... Oh, that's farther negative. 74,000 is about here? Okay, so I'm not doing anything right here. Yeah, it needs to be 84,000. Alright, so is there anything else that we're going to need to do? This repulse area, I might actually want to do a radius check on it instead of just a plus sign check. Yeah, you can see where it kind of is, right? It's like right here, and it's forcing stuff away. I think we need a radius check on it. So let's just do that. And if this doesn't look right, I'm gonna quickly switch over to drawing the repulse geometry right on the texture and just make sure it looks proper. Make sure I got the right, because it's not looking like what I would expect. Like I'd expect to see kind of an area there that things are moving away from, and I'm seeing just kind of after effects, and I think that's because the radius check is blah. Like the drain check doesn't have to be too big, too much. Like that's fine. We don't need it to really override the motion too much. But a repulse field, I want to have a very large effect. Alright, let's just draw it. I'm not seeing what I would expect to see. And eventually I'll probably expose some of more of this stuff so I can click on and off. There's only so much debug stuff I need at the moment. Alright, so let's just do this and then tick it once. And we should be seeing the repulse stuff, but we aren't. Yeah, alright, so There we go. We're looking at the drain map. And that is why it is really important to go through and validate your assumptions when you're programming crap, because you add something and you copy pasta the wrong Boolean array in there, and then you think it's okay because you're working on a complex system. And you're like, oh yeah, totally, that works. Just be thorough. Little bugs like that are the bane of the existence of everyone. And if you're thorough, you can actually go through and find them. And if you're not, you never find them. Ever. Until some designer throws down a repulsion field or something, and it's like, why isn't it doing it? You're like, well, I don't know what the hell. And then it's been 3 months since you looked at the code, and you're just like, ah, fuck it, just don't use those. Alright, so there are repulse fields. Interesting. So I need... Man. It's interesting to see right there. We actually have, because this object is not scaled like a square, our circles are not square. They're ovals. So what we need to do is, for drawing this stuff, we need like our, we need to do world to grid Y and X. Okay, so I gotta think about this for a second. How am I gonna do the radius check on this thing when it's not a goddamn... It's not a radius anymore. It's, we need to like multiply this by scale x and scale y for the distance. So I guess we want a, we need a float for like world to grid scale x and scale y. Stupid supporting non-square things. Okay, so what we're going to want to do is, one of them is going to be 1 and one of them is not going to be 1. So, so what it's going to be is, it's going to be like if the y value is greater than like this. All right, so what do we got to do? It's if the y stuff is greater than this, then yeah, okay, so we need to like float dx and dy. Dx equals alright, so if let's just have the return 1 right here. So if the y is greater, then we are a scale of 1. So if dy is greater than dx, return 1. Otherwise, return dx divided by dy. So if we are, let me just write this down. If we are 2 units wide, so we are 2 units wide, dx is greater than dy. So that means our y scale, so it'd be dx divided by dy, so it'd be 2 over 1. So our scale x would be 2. If it was y over x, then it would be 0.5. And when we multiply our x value change, we would take it less into account. No, our x value, it's actually going to be our dx divided by dy because we need a larger value. It's going to say the distance in the x is actually much larger because the scale in the x is larger. Which is correct. Like, the x value is greater. So you've got our dx and dy. So if dx is greater than dy, return that. Otherwise, dy divided by dx. Alright, so we need our scales to actually apply to our add repulse area. And our boxes are fine, we just need this other stuff. Yeah, so world to grid, then we need float scale x, and that's going to be flow field dot world to grid scale x. We don't need to pass anything in. Float scale y. Alright, so this will be so we need to multiply by the scale y in here. And then we need our grid radius X and Y again up here. Do we need to lock this? Oh, okay. It's gonna be. I guess we want to go from the greater one, so we need like int32 grid radius equals what the. I want to take the max value. Pass in grid radius X and Y. Well, let's see if it actually works. At least now we have it being drawn on the ground so we can see what our math looks like. We don't have to think it all through perfectly. So what we should see is basically a circle, not an oval. Stupid circles. How do circles work? They're them and their perfect circle curves. So we'll just be able to tick this once and see the output. Aha, that looks like a circle, doesn't it? Awesome. I knew I was smart. Alright, so let's tick this thing a few times and see what it actually does to these particles. Alright. Just wait for everything to load. It was pretty funny. Adam wasn't on a solid state drive for his development until like a little while ago. He's just sitting there waiting for stuff to load. Just like, what are you doing, man? You can see that repulsion field. See, that's what I would expect. Like a whole bunch of scattering. This thing just got all sorts of screwed up. It's like, but at least these things are like, streaming around properly. Alright, so the repulsion fields work. This thing is looking kind of like what it should, which is good. Now the other question is there any more that we can be doing with our inputs? Like, can we spawn more particles at the input point? Kind of on the edge of the radius of that thing? Maybe? Would that be worth anything? Because then we get more water flow coming off of it in the front. I don't think so. I think we can probably just get away with it. Not worry too much. I think that's good enough. Just like because we have this repulse field, everything's just all sorts of jacked up here. It's like all this water is getting pushed out. It's like, and then we got this water back here behind the waterfall that's just going straight to hell. It's like the water has no idea what to do. It's like flying off into the back behind the waterfall. That water's, if something gets trapped behind the waterfall, it's never getting out. Is that realistic? Can you get trapped behind a waterfall and then die horribly because you don't actually move out of it? Cool. Alright, that is, I think, good to go. Is there anything else we want to add to the particle stuff while we're touching the particle stuff? Let's see if we can just delete this rock here and redo this. Yeah, it looks correct. Well, I think that'll let us do stuff like if I can add like a tractor. I guess I should add an attractor thing as well. If I have a repulsor, like I can add an attractor and an attraction weight on it. Though, is that what we really want? Nah, I don't think so. I think we'll be alright just with this stuff. No sense in adding too many bells and whistles to this crap. It should just, it's not supposed to be a, perfect water simulator. It's supposed to be the okay water simulator 2015, right? Are still doing the water shader? Hello, Morton Barnes. Yeah. Yeah, I do not expect that we'll be finished with the water shading stuff for quite a while. Like if we get all the information done this week and we actually start on actually putting in like ripples and actual stuff that you can see with your eyes instead of see with your brain, um, I'll be really happy. And that's acting like how I would expect it to act. Like we got this turbulent area here, and then this is kind of like water does stuff there, and then flies off and around this. Yeah, we'd have lots of noise going on. Let's mess with this a little bit more. I'm just trying to make sure I got all the information that I want out of this simulation. Okay, so the only other thing I can think of that I might want to add would be a random vector or something like that. But I think we're getting what we want out of the flow field stuff. Like, I think it's good enough, right? Like, we're not... This is a pretty complicated bit of, flow area, and, it'll do what it does. It doesn't have to be perfect, it just has to be okay. Like those are all of our distances. That's our flow field, that's our height map. Alright, cool. So I think I'm gonna go throw some food on so I can eat said food when it is finished. Because I'm starting to get pretty hungry. Yeah, and we haven't done our dynamic flow field or dynamic obstacle maps. So the next thing that we need to do is we need to we did this like allow water particles to exit, water particles waterfalls, detect drains, detect the inputs and output of waterfalls. Yeah, so okay, so have repulse fields. So the next things we need to do are detect the inputs and outputs for water in the scene. Let's see. Yeah, food. Food is definitely something that is creeping up on me. It is exactly noon as well, so I mean that might have something to do with it. So next what we're going to do is we're going to detect the inputs and outputs of water from the scene geometry itself. So I'm going to have to think about exactly how to do that. But we've got this primitive component, and what I want to do is I want to look for things in the world, kind of like we've got this trigger volume, this trigger box here. And I want to be able to use, I think, the trigger boxes and stuff like that as like geometry that you can put into the world, and it'll just figure it out. So maybe like a little trigger sphere, like sphere trigger over here, and maybe you just have to do something simple to it to make it work. Maybe I can make some blueprints for these objects that make it real simple and easy to use. And the blueprints themselves will like attach maybe a tag or something, and I can fetch everything in the world that has like a certain tag, and then I can take a look at that and then add it to myself, because I can do that inside of these buttons. So I'm gonna go see what food is up there, and I'll be right back.